Thank you for inviting us, Jakob and the rest of you guys. What an impressive venue. Almost a little bit scary to stand down here, feel like a lecturer or something. I'm Anders, and this is Martin, and we are from Coana. And the first slide up there is the abstract that was in the invitation for Aarhus-JS. So let me just read that out loud to sort of set the stage here. It says, trying to end the days of overwhelming breaking changes, unresolved peer dependency issues, and endless security warnings. So that's basically the topic of what we want to talk about. But instead of going directly to the technical stuff, we're going to give you an introduction to what we're actually doing. We're a company, we're trying to solve some of these problems. And before we start going into the deep dives of the technical stuff, there's some context that we want to give you. So let's have a look. So for the next 20-ish minutes, we'll walk you through this very simple agenda. So first of all, I'll give you a short introduction to who we are. We've been doing some discovery work, so we're going to show you what it is we've learned about this issue of dependency management, and also give you an idea of what we're trying to do, and then get to the good stuff, do a demo of what we do right now, and talk a little bit about what it is we're trying to achieve in the next months and years. And then we left some time for some questions. And I really hope that if you have some questions, you'll just raise your hand also during the conversation or during the talk. We don't mind that you interrupt or ask. Actually, we would appreciate it. How's this sound? Is it okay or what? Very good.
It sounds louder up here than it does down
It feels weird down here, right?
Yeah. Up here. Yeah.
Very good. All right, first of all, we are from a startup called Coana. It's short for code analysis. That's why the name sounds like that. We're 4 people based in Aarhus. Established the company only 6 months ago, but it is a spin out from the university. So 3 of the co-founders, that's Benjamin, Anders, and Martin, are technical co-founders and also with an academic background. So they have been, prior to establishing this company, working with the topic of dependency management or code analysis for years already. I'm the only one, maybe in this room, basically, without a technical background. So bear with me. I think I'll show you in a minute what it is maybe that I'm trying to offer this realm. All right. So very short background on this. It's been a while since Martin and Benjamin started their academic research in this field, actually in 2015, so it's been a lot of years. But in 2019, their first publication that was sort of the foundation of what today is Coana was published. And then in between 2020 and 2022, you guys worked in parallel with your academic or during your academic research on a prototype that sort of laid the foundation of what we're trying to achieve right now. As mentioned, we started the company in September. And then we started doing something we call customer discovery work. And I'll get back to that in a minute because it's a bit important. But the most important thing right now is to say that just a few weeks back, we launched a beta. So a very tiny version of what we want to achieve in the final goal. And it's the beta that we'll demo later. All right, so starting point here. Package management. If you look at the State of JS survey, it comes out pretty clear that package management is the #1 pain among JavaScript developers. We've done some research that shows that 90% of JavaScript or Typescript developers handles packages and find it really important and an important aspect of their work. And digging a little bit deeper, we've actually found that almost 1/4 of all developers, JavaScript developers, are currently dissatisfied with how they manage packages. Not everything, but certain aspects of package management sort of triggers people's emotion or dissatisfaction. So this is another way of saying the same thing. It is also a developer meme, right? So for us, this tells us, maybe not the memes, but more the sort of the facts about this, that something is worth fixing or something is worth addressing And that is what we're doing right now. So to say it in one way, you could say it in numerous ways, but we're trying to relieve the pain of package management. But okay, relieving the pain of package management, what does that mean, right? Relieve, what does that mean? Pain, what pain? Package management, what does that mean? I think everyone in this room would have three different versions of what these three words or phrases mean. So we're trying to sort of dig a little bit deeper. So back to the same timeline as I showed you before. This is where the customer discovery thing gets really, really interesting. So we've been trying to sort of adapt a mindset of lean startups where we try to talk to a lot of people, try to figure out what we do before we start doing it. So that is just briefly what I'll show you before I come to the results of what we've learned, and then we sort of switch over to what we're then building. So 5-6 months ago, we started talking to people. So we've done tons of interviews with developers, architects, DevOps, managers, trying to understand, okay, how does this beast of dependency management look? And I can sort of say to you that it's really, really complex, like different mindsets, opinions, contexts, experience, like everything is very, very complicated, or it has a lot of different facets, right? So to try to get something out of this information that we got, we actually ran a quite big study with 120 developers trying to quantify all the stuff we learned. I'll show you in a minute what that led to. And then we've also had several technical advisors that have given us really, really fruitful feedback that we've been using continuously to learn and to sort of conceptualize what we think we're trying to do. So this is, the idea is here to try to build a build, measure, learn loop that we can use as we try to figure out what we need to solve and for who and how. But obviously, this is not all about speaking to people. We want to build something. So hopefully, really soon, we can sort of change this thing. Instead of talking to people and trying to interpret what they say, we can look at people using our products. And this is where we'll get to in a minute. But this is the last thing I want to say before we jump into the more product-related or the stuff. So I think we want to look at this slide just for a minute. It's the first discovery work we did. We tried to uncover, okay, what are the biggest unmet needs? So in this terminology, unmet needs are not necessarily the most important things, but they're the most important things that people are dissatisfied with for some reason. Maybe because they're not good at it, maybe because they don't have the tools necessary to solve it. It can be anything, so there's so much sort of layers underneath this. But I just want to read them out loud, and maybe you guys can think about whether these are true for you or not, or it looks completely different for you. So we see that people have issues with detecting and fixing breaking changes. It's a challenge. It's phrased like challenges. It's a challenge to handle peer dependencies. It's a challenge to address security vulnerabilities. It's a challenge to gather information about packages when updating. It's a challenge to get notified when technical debt accumulates. And it's a challenge to minimize the risk of malicious packages. So these are still very high level, and there's a lot of nuances to it, but it sort of gives you an idea of what is currently not really solved, at least for a substantial part of the developers we talk to. So this brings us to the next thing. This was all the context. This was what we've learned and what we're trying to solve. And that's the cue for me to shift the microphone, so just bear with us for a minute. Yes, sir.
Also the other microphone. Yeah.
Oh, yes, thank you.
All right, so how's this? Does it sound okay? okay. Ah, okay. Still looks to be in. It's coming. All right. Good. So, right, the next thing I want to show you is basically what we plan to do over the next couple of years. But before I do that, I just want to briefly show you what we have already worked on. And I don't know, how is the resolution?
Zoom in a little bit.
Zoom in. Okay. Is that okay?
Yeah.
All right. So what we have been working on so far is an extension for VS Code. So how many of you use VS Code regularly? Okay. So, it seems like most web developers use VS Code, at least sometimes. Some people still use JetBrains or other IDEs. But basically, in VS Code, you can write extensions, as you probably know. And what we have done is to write an extension that is going to help you, or that can help you with package management. And currently, what the extension does is quite a lot of the same things that you can get out of, for example, the npm CLI. We just presented in a GUI, but we also have some things already that the npm CLI cannot do, and which, and then we have, I'll show you later, we have some elements on the roadmap that we're going to add onto the extension later. All right, so what I have open at the moment is just an old TypeScript project, which we haven't worked on for some time. It's a mono repository managed by this tool called Learner, which I'm sure some of you are familiar with. So you see that we have a lot of different sub-projects, and each of these sub-projects all have their own package.json file. So right now, I'm in the extension, and I have opened one of these sub-projects called Backend, and the package.json of this Backend project. And what you can see is that I can see which packages are vulnerable, so affected by known vulnerabilities, and I can see which packages are updatable, so packages where new versions are available. All right, so let's filter for the vulnerable packages and take a look at one of them. For example, this latest version package. We can see that there are two different vulnerabilities. One related to this God package. So if you open it or expand it, you get some metadata about this vulnerability, for example, the advisory URL, but you also see the path through the sub-dependencies that trigger this vulnerability. So we depend directly on latest version, which in turn depends on this package called package.json, which in turn depends on God. And similarly for the other vulnerability. So basically what you get here is just a GUI representation of what you are probably already familiar with from the npm audit tool. All right, so the other element is about updates. So we can see here that there is that we're currently using version 5 of latest version, but it's possible to update to both version 6 or to version 7. And in either case, we will automatically link to the changelog, so you can see what changes were made. Another thing to notice is that it says that no peer dependency upgrades are required. So basically, this means that you will not get any complaints from npm about peer dependencies if you do this update. If we look at something like TS Node, you see that we are currently using version 8, but it's possible to update to version 9. But if you do that, you also have to upgrade Typescript, otherwise you get a peer dependency complaint. So you get that kind of information upfront instead of after you have done the update. All right, but the element from the extension, which is sort of the secret sauce, at least compared to what you already get from npm, is this notion of API usage. So what API usage gives you is a metric to show you how much you use each of the dependencies. So you can see that a dependency like Lodash or RxJS is used quite extensively in this package, whereas some other dependencies like Rimref or NodeMailer are not really used that much. So there can be multiple reasons why we have 0 API usages. Could also be that it's a package that is only used in a script. So like in the script section of your package.json, but not actually used in any of the code. In that case, it will also show as having 0 API usage.
Is it only your usage of it, or also other dependencies usage?
No, it's only your usage in your code. So nothing in sub-dependencies. So this can, of course, help you determine if you actually depend on some packages that you actually don't use, which is quite helpful. But you can also browse through the API usage. So if you take a package like, let me see, like Mobex here, for example, you can view the API usage. Then you can see, okay, at which source locations do you actually import the package. So you can jump to the various files where Mobex is imported. And you can see that we use these 2 different APIs, make observable and when from Mobex, and then also jump to the source locations where those APIs are used. And the intention of this is that it can technically help you complete upgrades, because if you have a changelog describing that no breaking changes takes place in the update of Mobex in the make observable API, then you know that that in the make observable or the when API, then you know that you don't have to make any changes to your code to complete that update. All right, so that's basically what the extension does for now. Still fairly simple and fairly early work. And there's lots of things that don't work yet. So for example, only works with NPM. So if you use PNPM or Yarn, it's going to complain at least some of the features. And there are also some GUI elements that could be better. If you have a very large enterprise project, it's very likely that the API usage element might take quite a long time to actually compute for your project. But these are all things that we are actively working on. If you want to try it, you can find it in the marketplace where it's called Coana. You just search for Coana and you find the extension. All right, but let me now talk a little bit about what we are planning to work on over the coming couple of years. So we have a roadmap. This is not a roadmap that's set in stone, so it's probably going to change quite a lot, but at least that's what we sort of intend to do based on the knowledge we have at the moment. So each of these elements on the roadmap address one of the unmet needs. So for example, there is the challenge of detecting and fixing breaking changes. So what we propose to do here is to use a technique from the academic world known as semantic patches. So semantic patch is basically a formalization of a changelog. So imagine writing a changelog as a program instead of as text or as like human language. You write it as a program. And then this program describes both where breaking changes take place and potentially also how to fix the breaking changes. And this gives you a code migration that you can use to automatically address breaking changes. So we've been working on that for a long time. It's not the feature that we think will focus on for the next coming couple of months, but at some point we plan to put quite a lot of effort into that. The challenge of handling peer dependencies, I already showed you that we are doing something in that direction using something we call a peer dependency graph. That's something that we have implemented on our backend, and that is what allows us to answer queries like understanding if an update of some package is going to result in peer dependency constraints breaking on other packages. Then there's the challenge of addressing security vulnerabilities. So you are probably familiar with tools like npm audit, Dependabot, Sneak, maybe Renovate, that just give you warnings if you depend on a package that has a known vulnerability, but they don't actually consider if you actually use the vulnerable part of this package. So that is something that we are currently working quite actively on implementing, using roughly the same type of analysis that we use for the API usage in the extension at the moment. And this means that if you're used to getting like 50 or 60 vulnerability alerts every time you run npm install, this will allow you to focus on the very few vulnerabilities that are actually relevant for your project. Then there's the challenge of gathering information about packages. That's sort of a very broad challenge, and I'm not sure we have the answer to the sort of the very broad issue, but at least we have the VS Code extension now that can help you with some of the issues that belong to that category. The challenge of getting notified when technical debt accumulates. So again, we don't have the full answer for this, but we are working on CI integrations and potentially also at some point some dashboards that can provide you with information such as how outdated are your dependencies, do you depend on dependencies that are not actively maintained anymore and where you should probably at some point look for alternatives, and questions like that. And then finally, there is this famous issue of malicious package updates. So you've probably heard about those scenarios where some package gets hijacked by a malicious developer who then releases an update that suddenly starts to steal, for example, private keys from the computers where this update is installed. And it would be extremely beneficial if we can detect that kind of behavior up front. Now that's very difficult to do, usually because developers try to hide the malicious behavior using code obfuscation, for example. But we are, as part of the sort of the more research direction of Coana, we are looking into ways in which you can use code analysis to detect malicious updates. So yeah, that's the roadmap from us. And yeah, I already gave you the demo. So I'll just move on to the Q&A and ask if any of you have any questions or comments or... Yeah?
One of the challenges we have is we have a lot of projects and a lot of libraries. And when we run npm audit, it's going to print out like 6 billion things that we could fix. But actually picking out something, from that enormous list, so we have like, let's say a quarterly security review or something. What the hell do we actually do? We have X amount of hours and we have all these thousands of things we could address. Prioritizing them is also a bit of an issue, honestly.
Yeah. Yeah, so that makes sense. Do I have to repeat the question or? But okay. It's all right. Okay. Yeah, so prioritizing which security vulnerabilities to fix. I think in an ideal world, we would always fix vulnerabilities as soon as they appear. But of course, that can be very challenging to do. We also have other issues. And this is where I hope our vulnerability scanner can eventually help, because it will show you not only all vulnerabilities, but sort of provide a filter that lets you focus on the ones that could potentially be exploited in your project. Another issue is, I think many people are familiar with, is that if you're developing a front-end app, then there are lots of vulnerabilities that are probably not relevant to your particular context. And it would also be nice to have some kind of mechanism that could somehow determine that this program is running in a context where this particular vulnerability is actually not relevant.
Does it work for both Typescript and JavaScript? And if so, do you get better insights with the Typescript version, or do you do all of the tracing yourself?
Yeah, so it works for both JavaScript and TypeScript. Currently, it mostly uses the JavaScript information. So you get a little bit of extra information if you use TypeScript, but we don't leverage it as much as we plan to do eventually. Yeah, but there are some frameworks and like special syntaxes it doesn't work with yet. So it should work with React and partially with Angular, but not with Vue, for example.
out where you could detect if your code is using packages that has vulnerabilities, but also detect if you are actually using the vulnerable part of the package. How are you going to do that? Because vulnerabilities, they are not tracked in a technical way, are they?
So there are some databases that basically try to map a vulnerability to a particular line of code. It's not always possible to do it, but for some vulnerabilities you can do it. And in that case, you could ask a static analysis to try to determine, is it actually possible for this line of code to get called in your particular application? So that's roughly the question we're trying to answer. But we have to either get access to those databases, or we have to sort of create our own database. So we have to look at every vulnerability and try to map it into something our static analysis can understand. Yeah.
You mentioned in half a sentence, or maybe I was just zoning out for a second, stuff about sometimes recommending alternative packages, or like packages that are dead but replaced by something else, or like how would that work in practice?
I don't think we plan to do that. I think as a first step, we would try to compute if a package is unmaintained using some different metrics. And there are already other companies, other people looking at that issue. I don't think anyone has found the perfect solution to that yet. But there are various tools that try to give you like I think Snyk and Debricked try to compute whether a package is not well maintained. But of course, the issue is sometimes you have very small packages where the logic is basically supposed to stay the same over time, and that doesn't necessarily mean that the package is unmaintained.
But I guess it could be pretty cool. Like in the example you showed Lodash, and that made me think of underscore, right? And underscore is a pretty good example of something that if you find underscore, you should probably say, go use Lodash instead.
Yeah.
Or at least in most cases you could.
Yeah, good point.
How's the pricing model? I'm guessing there will be one. How's that going to work out? Do we have like a free extension, and then some of the hosted dashboard features are what you're going to pay for? How do you intend to monetize it?
Yeah, I can answer that question.
I figured
You basically answered it yourself. Yes, but right now we only have assumptions on how that's going to work. But what we know is that for sure there's going to be a free product, and also pretty broad in its feature set for individual developers or small teams, and then we'll put on like team features or enterprise features on top of it. But how exactly that is, we don't know yet.
I could see the dashboarding and stuff like that being an obvious thing for organizing larger projects and code bases.
Yeah, good point.
But the extension stays like a free component.
Yeah.
Any plans for anything other than JavaScript-based programming languages?
No, not really, no. So the analysis is very specific to JavaScript, so we would have to start all over, and that would take a lot of resources. But yeah, it could be interesting.
It's in a far future.
Yeah.
No immediate plans.
No.
For sure.
I know you're looking into at some point also creating a CLI to maybe use this in a more kind of CI/CD setup or more automated fashion, scripted fashion. Is that a plan?
Yeah, it is. We are actively working on that.
Okay.
Quite actively, actually. So, yeah.
Can you imagine that works? Because I think, to me, a lot of the power of the tool that you showed off is that you see the information and that you, as a person, makes decision based on that. And that doesn't really work in a CI/CD kind of work where a machine does all of the work. Like, how do you see that work?
It's a good.
How is it better than just doing npm update that way?
So right now, it's not much better than doing npm. Apart from, we think that some of the data that npm produces is quite difficult to parse. So if you try to get it to spit out, for example, the audit data as a JSON object, which you can do, then going through that JSON object is very, very difficult. I basically spent weeks trying to understand it, and I couldn't. So I think we can provide it in a better format, but of course the intention is also to provide some of these more analysis-based features over time. So you would get access to the security scanner, for example. Right now you also have the API usage element, so you can also, technically you can also set up a CI pipeline that says, for example, you don't want it to pass if you have a package that isn't being used, for example. Nice.
Will it work with Dino? Only node-based setups?
Well, isn't Dino supposed to soon work with node-based setups? I'm not sure, probably not. That's a good question. I'm not super familiar with Dino. I think it should technically be possible for us to add support for Dino also. So we have found that adding support for frameworks is not that difficult, and I think in some way you could view Dino as a framework, but maybe I'm wrong in that assumption, and it turns out to be very difficult. So we'll see.
On the same note about frameworks, like you mentioned that it works with React and Angular, and it doesn't work with Vue. So I'm assuming that also it doesn't work with meta frameworks like Nuxt and Gatsby and stuff like that.
No, probably not. Like in general, if it has any kind of special syntax that isn't native to JavaScript or Typescript, or isn't similar to React, then it doesn't work at the moment. Then we need special support for that. Sure.
So Node had sort of a big split going from the whole require thing to the import thing. Does your analysis work for require, which is like a super dynamic thing where strings can be concatenated and a lot of other crap, or does it work reliably with import?
So you can certainly construct a program that the analysis is not able to handle well, but it actually tries to handle strings also. So depending on how evil your program is, it will work. But yeah, dynamic imports could be an issue.
Very good.
All right.
Thanks for all the questions.
Yeah, thank you.